already learned how to add like monomials, and now we're going to learn how to subtract. Very simple. Basically, just the opposite of what you would do with the coefficients. Remember that for them to be like monomials, the exponents and the variables have to be the same. Here's a little picture of some wooden blocks. You can kind of see that the original volume of the block has changed. We've subtracted some blocks from it. This is an example of subtracting monomials. For example, each of these little blocks would have a particular volume, let's say x cubed. And if we're taking the larger block, the volume would be that many more times, maybe 27x cubed or something like that, just looking at the diagram. So it'd be, if we wanted to figure out the remaining volume, it'd be something like 27x cubed minus, I don't know, 8x cubed, maybe 19x cubed. So there's a pretty good illustration of what it might look like visually to subtract like monomials. Let's go ahead and jump right into the first example. We have negative 3x minus 9x. Now remember, in order to add or subtract like monomials, the variables have to be the same. In this case, they are. Well, just like adding like monomials, the only difference is we will be subtracting the exponents. Step 1, make sure the variables and exponents are identical. We've already done that. Step 2, fill in the missing parts. So for example, if there was no coefficients, we would want to make sure they're there so that we can appropriately subtract them. Now the only difference between adding and subtracting like monomials is step 3. In this case, we're going to be subtracting the coefficients. I'm going to show you why here in just a second. But for now, let's take a look and see. We have negative 3 minus 9. Okay? What is negative 3 minus 9? It's negative 12. Okay? Now, if we were adding them again, if it was negative 3x plus 9x, it would be negative 3 plus 9, which is 6x. But because we're subtracting them, we subtract the exponents. Negative 3 minus 9 is negative 12x. And just like with adding like monomials, the variables and the exponents stay the same. So since it started out with x, you end up with x, okay? Why is that? Well, we're going to show you in just a second why that is. For now, just make sure that you keep the x's and the variables the same. And then simplify. So make sure that your final answer is as simple as possible. Negative 12x is good. And so that's it. We've simplified it completely. Now I want to show you why we subtract the exponents. Let's say we have 9 apples. So we're just going to say 9a, variable is a, and we subtract 7 apples. I think everybody can see that if you started out with 9 apples and you subtracted 7, you'd end up with 2 apples. That's the easiest and simplest explanation I can think of. This is why we subtract the exponents. Now notice, the variable stays the same. It's not like it's 9a squared or something weird. It's still 2 apples, okay? So sometimes we want to overcomplicate things in math, when in fact it's just that simple. You just want to subtract the coefficients. Next example. We have 3x squared minus 2y squared x. Now it looks different. Step 1, we want to make sure the variables and exponents are the same. Even though it looks a little different because of the order, in fact they are the same. They both have a y squared, they both have an x. Okay, and so what we need to do in this case is just reverse the x and the y squared here. So now we have 3xy squared minus 2xy squared. We can easily see that indeed the variables and the exponents are the same. So we already know what to do. We're going to make sure that we fill in any missing parts. In this case, we just want to make sure that they both have coefficients. And then we want to subtract the coefficients. And so just like we said before, we could consider this like an apple or something for the variables. 3 apples minus 2 apples gives you 1 apple, okay? I'm going to put the coefficient there. 3 minus 2 is indeed 1, okay? And so now we have 1xy squared. Remember that the variables and the exponents stay the same, but we do want to simplify that. So 1 times anything is itself, and so when you end up with 1xy squared, you don't really need that 1 there. You can just write it as xy squared. So therefore, 3xy squared minus 2xy squared gives you xy squared. Next example, we have xyz minus xyz. Now, what happens when you subtract something from itself? Well, just think about this, okay? X, y, and z are all numbers. So you can imagine that this is going to give you a number, and this is going to give you the same number. Let's say they both give you 20. What's 20 minus 20? 0, right? I am going to show you why it's 0, but that's kind of a shortcut. If you subtract something from itself, you get 0. Now, if we do it the long way, make sure that you fill in any missing parts. Now, you don't really have to for this one, but I'm going to go ahead and put 1 there and 1 there. And you don't have to put the missing exponents, but you can if you want to. We just really need these coefficients. Now, what is 1 minus 1? So I'm going to ask you. Once we make sure the variables and exponents are the same, we can subtract the coefficients. What is 1 minus 1? 1 minus 1 is 0, so we get 0, x, y, z. Now, if you take 0 and multiply something, if you take 0 and multiply anything, you get what? You get 0 back, right? And so when we go to simplify this, yes, it is 0, x, y, z, but 0 times anything is 0. Therefore, your final answer is 0. That's pretty simple, right? That's why the shortcut's important. You have to go through all those steps. Just know that when you subtract something, anything from itself, including a bunch of variables, you're going to get 0 back. Next example, we have 2x cubed y to the fourth minus 2x to the fourth y cubed. This is something you might see on a multiple choice test. If you just quickly glance at this problem, it looks like you get 0 again. But if you investigate closely, you'll see this x has a 3 as an exponent. This exponent has a 4. Conversely, this y has a 4 exponent, and this y has a 3. The exponents that are associated with the variables have to be the same. You can't just, pick and choose, well, they both have 4 and 3. No, because the exponents are different associated with the same variable, you cannot subtract those. Okay, you can't add them, and of course you can't subtract them either. And so for this particular example, you can't simplify it. Now students might ask me, what's the answer? Well, the answer is actually what you started with. All you'd be able to do with this problem is just rewrite 2x cubed y to the fourth minus 2x to the fourth y cubed. That's as simple as it gets. You can't combine them because those exponents that are associated with the particular variable are different. Example 5. Sometimes what is you end up subtracting more than once, and that's fine, okay? It's real simple. We can see here that the variables and exponents are the same. It's all x to the fourth. All you really need to do when you have multiple subtraction is just subtract the coefficients again, but just do it 3 times. 19 minus 7 is 12. 12 minus 5 is 7. Therefore, your answer is 7x to the fourth. Real simple. You can do it multiple times. It works just the same as adding, subtracting normal numbers. I actually jumped an example. We'll go back and do example 5. We have negative 3x squared minus 5x squared plus 7x squared. When you have, so again, the variables and exponents are the same. In this particular example, you actually have a subtraction problem combined with an addition, and it works just the same. You just want to do the order of operations, go from left to right when you're dealing with adding and subtracting. Whenever you work it out, that's your answer. So for this one, you want to go ahead and do negative 3x squared minus 5x squared first. Negative 3 minus 5 is negative 8x squared, so that's subtraction. Then it turns into an addition problem. Since you're adding like variables, you want to add the exponents. Negative 8 plus 7, and I will show a little bit extra step here. Negative 8 plus 7 is negative 1x squared, and then negative 1x squared is just negative x squared. So you can do an adding and subtracting problem at the same time. Just make sure that you work from left to right, and it's that simple. So that's putting both adding and subtracting like variables into the same problem. That's it for subtracting like monomials. You can add and subtract like monomials. Just make sure you work from left to right. Make sure the variables and the exponents are the same, and then just combine the coefficients. If you have any other questions about this lesson, let me know.